Assalamu alaikum. I welcome you all to this fifth lecture of CS 116 Object Oriented Programming. So let's get started. This is what we have been doing previously in this course. We have seen the concept of objects and classes. We have seen some prime features of object oriented programming paradigm: encapsulation, data hiding, inheritance, polymorphism, association, and its types. And we also saw how to make class diagrams using UML, and we also explored this software star UML. Now, up till now, what we had been doing was kind of theoretical only, in the sense that we weren't using any programming language to see how these features are implemented. From now on, we'll start Python, and we'll see how these features and many other features, these are just a few, they are implemented in Python, or what support Python provides for all these features. Today we'll see how we can define classes in Python. We know that there are some built-in data types in Python, like integers, string, floats, lists, etc., etc., and they are all defined via classes, right? Like they are all classes by themselves, right? So after learning the syntax for defining classes, we'll be able to define our own types, right? So what we learn today, we'll see how the basic syntax for defining classes, how we can add attributes and methods to a class, and then we'll see how you can document a class using doc strings. And fortunately, we know what doc strings are, so we'll just see how that can be applied to classes. We'll instantiate objects for that, for those classes, and then we'll do a lot of coding examples today. Now let's see syntax for defining a simple class in Python. Here, class written in green is a keyword. Now from now on, I'll use this convention in my lectures, that whenever I'm discussing syntax of any particular structure, I'll use this green color to define the fixed things, the keywords, or other things that are part of syntax, like that colon at the end. So green color means that you cannot change it at your own discretion. So how you can define a class? You use this keyword class followed by class name. Now class name could be anything, as long as it follows that simple variable name rule, right? So you can name your class anything. This statement, it ends with a colon, like all other Python structures do. Now after that, in indentation, you start defining your attributes. Now the first line, attribute 1 is equals to value, means that you provide name to your attribute. Attribute 1 means the name, and you can assign it some value, right? Actually, the thing which is different in Python is that here value will be some kind of object, like integer or float or list or some object of some different class. So actually that carries the weight. And attribute 1, which is going to be a name, is just going to be a variable name associated with that objects, right? And we'll see that this initialization is essential here, because you cannot just write a name in Python and just get away with it. You have to link it to some variable name. I'll come to this point later when we see the examples. So the point here is that you can use a variable name is equals to some object, and then you can define as many attributes as you want, right? Now after defining your attributes, you start defining your methods. This is how you can do that. Now if you observe, this syntax is almost similar to the one that we use for defining functions. This def keyword is familiar to us, followed by the method name, and this method name again could be anything as long as it is following that variable name rule. Then in round parentheses, you put the list of arguments, right? And after specifying the arguments, you put a colon, which is standard, which is the standard way of ending a structure in Python. And then using indentation, you can provide the implementation for this method, right? Like the body of that method is indented. And that's how you can define as many methods as you want. The main difference between a function that we had been defining last semester and this method, which is part of a class, is this word written in red, self, right? Now let's see what this term self means. Now this term self, it actually represents an object, um, instantiated object, and an instantiated object can also be called an instance of a class, right? Now I told you previously that the attributes and methods that you define or you invoke on one object, they do not interfere with attributes and methods invoked on any other object of the same class, and that happens because of this word self, right? We'll see in the examples coming after this slide that how this self is actually mapped with an object name, right? Or how an object or instance name replaces this self upon execution. But the point here is that this is the main thing that differentiates one object, contents of one object, from that of the of any other object, right? Of the same class, of course. Now I have not written this in green because actually it's not a keyword. Most of the Pythonian community use this word self, but this is not a fixed word. You can use anything here. Like if I give you an example from other languages, in C++ and Java, they use a fixed word, and that is this, 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 right? So they use this to refer to attributes and methods of an object, right? But and there it's a keyword, it's a fixed word, but here it's not a fixed word. You can use self because most of the Pythonian coders use this, but you can use any other name here as well. Like you can write this instead of self, or you can assign any other name of your choice here. But again, if we restrict ourselves to one convention, that helps us in making less errors while coding larger programs, right? So let's stick to self. I'll always use this term self, but you should keep it in mind that it's not a keyword. Now if I recap this syntax, you use that class keyword, right, to define a class, followed by colon. Whole body of the class is indented, right? You first define a list of attributes and you have to initialize them. If you don't initialize them, we'll see what will happen and what are the solutions to that. And after attributes list, there comes methods list. You define methods almost the same way as you do in functions, except for this word self, which is not there in functions, and it is essential part of parameter list in methods, and it has to be the first argument. It's always the first argument, and after this word self you can give the list of your regular arguments, and regular arguments could be 0 to many, right? Now let's see an example. In this example, I am defining a class called animal, and this class animal will have two attributes, species and language, and I'll define one method for this class called speak, right? Now this example is going to be my favorite example for today. Like I'll be highlighting different features of class definition and object instantiation using the same example. So just pay attention so that you find it easier later to follow, right? Now talking of this function method speak, what this method will do, it will simply print a message. I am a cat and I mew. For example, this is a message. Now the special thing about this message is that it is not a static string. uh, in this string, the term cat and mew, these are actually or these are going to be the objects associated to those attributes, species and language. For example, for an object, let's suppose I define species to be equal to cat and language to be equal to mew. So basically my method speak will be picking those attributes of the same class. So let's see how we can do this. Now I'm defining a class using this class keyword, followed by the name that I have chosen for my class, which is animal, followed by a colon, right? Now this is my first attribute. I'm calling this attribute species, and this species is simply a variable name linked to a string object, and the value assigned to that string object is cat, right? So cat is a string object, and it has been linked to a variable name species, which is actually the attribute name for my first attribute in my class, right? Similarly, I can define another attribute, and this time I name it language and I link it to another string object called mew. Now see, in Python this initialization is necessary. Like you cannot just simply write species and language as two attributes and you can initialize them later, because in Python, these variable names, they are nothing by themselves. Actual importance is given to the objects. So cat and mew are objects and they are linked to those variable name. So whereas in other language this does not happen. There you can define a simple variable name and that variable name actually carries all the weight and then you assign a value to it. But here that is not the case. Here object has the main significance and variable names, they are just the names or their identifiers for those objects, right? So the problem here is that you cannot just use these variable names alone. You have to initialize them or link them to some concrete objects. We'll see later how to overcome this problem, but for now we'll be using this convention. So that's how I have defined two attributes of my class, species and language. Now let's talk about this method speak. Now, as you can see, def is the keyword, speak is the name of my method, and self is that essential argument that has to be there in every class method, right? So I cannot eliminate that. Apart from this, you notice here that I am not passing the other two attributes as argument here. Now, I don't remember whether I told this to you before or not, but the attributes in a class, they are accessible to all methods of the class by default. Like you don't need to pass them as parameters to class methods, or you do not have to use that global keyword even here, right? These are automatically accessible to all the methods of the same class, right? Whether they are defined public or private or protected. Now, having said that, one more thing that comes to my mind right now is that all the attributes and the methods that we'll be defining in today's class, they'll be public. Like in next class, we'll see how you can make an attribute or a method private or protected. But for today, all the attributes and all the methods, they are going to be public by default, right? So this is how we initialize this method speak. We don't need to pass those attributes species and language, just one attribute self, which is the essential first parameter for every class method. Now, within the body of this method speak, I just need to write this one print statement, right? Print, and there's a string there. This string which I have given here for this function print, let's see what it means. Now, the first part of this string, I am a, you can see these are placed within those quotes. So that means this will be printed as it is, right? Now, after that, the second term is self.species. Now, this self.species is there to access attribute of this class animal, right? So basically, this term self.species, it will be replaced by this object cat upon execution, right? Now, the important point that you should remember here is that whenever you are accessing an attribute of a class, you have to use this self dot kind of keyword, right? So if you do not write this self dot, what will happen, we'll see that later in today's lecture, but for now you just remember it that this is part of a syntax. Whenever you want to access an attribute, you have to write self dot and then the attribute name. So self.species means that I am accessing the first attribute, and upon execution this will be replaced by the corresponding object, which is cat. So I am a cat, then comes this part, and I can, this is again a static string, and self.language, here I am accessing the second attribute, right? Self.language will be accessing or will be replaced by this object mew upon execution, right? So that's how we can form a string which actually is using the attributes of the same class. Now this is the blueprint of the class. Now let's instantiate some objects of this class. That I'll be doing in the main code or the main program. So this is the statement where I'm instantiating my first object. Now the name of the object that I have chosen here is A1. A1 is my first object, and in order to instantiate to this class animal, what syntax I have used here is that A1 is equals to name of class, which is animal, followed by a pair of empty round parentheses, right? So in this way I can instantiate this object A1. This is my first object. Now this object can access the attributes and the method of this class animal using the dot operator, and we are familiar with that, right? We have done that previously also, like we used to call invoke methods on class list and on that class string using this dot operator. So if I want to access that attribute, that attribute species, I would write a1 dot species. And if I want to access language, I would write a1 dot language, or similarly I could write a1 dot speak, right? So this is my first object. Now this first statement is just printing the first attribute. I have some constant string here, this part, right? This will be printed as it is, and this a1 dot species, it will actually pick that that object cat, right? Similarly, I can access the second attribute, right? A1 dot language, it will pick the second attribute, and here I'm accessing that method speak. Now speak itself prints a statement, so I do not need to put it into any other print statement explicitly, right? Now let's see what output will this code produce. Now this first line, this one, it will print this thing as static. First attribute 1 of animal, it will be printed as it is, and a1 dot species, it will pick the object cat. So this is the output, right? Now similarly, the second statement, this one, it will print attribute 2 of animal, and then a1 dot language will pick mu. So attribute 2 of animal is mu, and the last one, that method a1 dot speak, this one, this will simply invoke that method speak. Now speak will itself collect those attributes, and this it will form this statement, it will print it on the screen. So this is the output of this third statement. I am a cat and I can mew. See, so this is a way, simple way by which you can define a class and then you can instantiate an object of that class. Now let's see how I can change the values of those two attributes, species and language. There could be multiple ways to do that. The first method that we are seeing is by accessing those attributes and changing them directly. So here's the code that we saw on the last slide. Okay, now this statement, last statement, shows that I have instantiated an object called a1. Now I can access a1 dot species and I can directly reassign it to a new value. Like in this case, I am assigning it to this new value line. Similarly, I can use the second statement to change the value of that second attribute, language, to rower. And now if I print this, then it will access the new value of this attribute species. Similarly, this statement will also access the new value of this attribute language. And this function speak, now it should print that I am a lion and I can roar, right? Now let's see what output does it produce. Okay, the first print statement is attribute 1 of animal. See, attribute 1 of animal colon line. So a1 dot species is retrieving this new value line, right? Similarly, attribute 2 of animal is roar, and last statement speak. Okay, this is what we expected. So it is printing the same thing, right? So this is one way of changing the values of these attributes. That means that we are directly accessing those attributes from the main program and we are reassigning them these values. But you see, the problem with this method is that the concept of data hiding is being violated here. Like we don't want a user of our class to access those attributes directly from the main program. So let's see a second approach to overcome this. Obviously, second approach will contain setter methods, and let's see how that works. Okay, now this is the code that we saw. Now let me define some setter methods here, two setter methods because I have two attributes. Now this first setter method, it sets value for species. So first argument is self, which has to be self, and second one is any value s passed by the user. And within this method, we'll just assign this s to species. Now since species is an internal attribute, so it has to be accessed through self dot operator, right? Whereas s, since it has been passed from outside, so it remains as it is. Similarly, I can define a setter for language, and it assigns this L to the internal attribute language. Now, how we use it? We instantiate that instance a1, and then a1 dot set species will be used to assign a new value to species. Now you see, now I don't have to access that attribute directly. I'm calling this setter function, and it is resetting its the value of that particular attribute. Similarly, set.language, it helps me access the second attribute, and then I'm calling the same function again. Now let's see what the output would be. Now if you observe here, none of the statements is printing except for the last one, because a1 dot set species, it's a setter function, it's not a print statement. Then a1 dot set language also doesn't print anything. Only the last statement, a1 dot speak, it will print a particular statement, and it should use mouse and squeak. So see, this is the expected output. I am a mouse and I can squeak, right? Now let's see one more way of doing the same thing. Like I want to change the values of those attributes, or you can say I want to custom set those values. So consider this code now. Now, if you observe, this code is almost the same as we had on the last slide, except for one thing. Here, I am not defining those two attributes, species and language, explicitly, right? Since I'm not defining them explicitly in the class, I don't have to initialize them, because Python doesn't allow me to define an attribute without initializing them, because of the reason that I discussed in the last couple of slides. So here, what will happen? When we call this function, this method set species, what it will do, it will define this attribute for the first time, because we know what happens in Python. Whenever you access an attribute or simply a variable, it sees if that variable or that object or the object to which that variable links already exists. If that already exists, it uses it, and if it does not exist, it simply creates it. So when we'll execute this method set species and we come to this specific line, since there is no attribute species defined before, so Python will define a new attribute known as species for us, and it will be assigned this value s. Similarly, when this function is called, so this function will define this second attribute language, and it will assign this value L to it. So that means that we can directly create an attribute and assign it value at runtime. We don't have to initialize it here in this case, right? So let's see how it works. I'm instantiating an object a1, then a1 dot set species. Now this method, it will initialize this attribute species to s. In fact, it will first create this attribute, and then it will initialize it to s, which is equal to mouse in this case. Set language will create a new attribute language, and it will assign it this new value squeak, and then we can call this function. Now let's see what the output of this code is. Acha, okay, now I'm not showing you the output here. You know what will be the output. Obviously, a1 dot speak function will print that I am a mouse and I can squeak. Now, what the problem with this approach is, let's see that in this right-hand side code. A1 is equals to animal, it will instantiate an object. Now, let's suppose if I try to access this object, a1 dot species, before you calling this function set species. Like in this case, if you see this statement, here I'm trying to access this attribute. Obviously, I can access this attribute, but the problem here is that this attribute is created after this method is executed. But So if you try to call this attribute accidentally, if you try to access that attribute accidentally before calling the set function, this will result in error. So let's suppose I call the set functions after calling a1.species and I repeat the whole code. So this statement will produce error and this code will not run. So the problem here is that you have to take care that you don't access any attribute before its definition. And these attributes, they are actually defined in this set species method, right? But the good part about this is that you don't have to initialize those attributes at the start of the class, right? Now, one more thing, in fact, not one more thing, in fact, a similar approach is defining getter methods. So this is the code. Let's add some getter method to it. This is the first getter method. If you recall, getter methods simply allow you to access the value of an attribute. So it will simply return that specific attribute, right? Self has to be there because it's a method within a class, and it will just return the value of this attribute species. Similarly, I can define another getter method, right? And this will return value of language. Now, if I write this code, this will work absolutely fine because first I'm setting these two attributes, species and language, and in the last statement, I'm using this get function to access that attribute species. Now, this is a good approach because we learned in past lectures that we need to hide data from the user. That is one of the main features of object-oriented approach. So accessing these attributes through getter and setter and not accessing them directly is a good way of programming in OOP paradigm, right? So this code will work perfectly fine because we are setting the values of species and language first, and then we are accessing it. But this code here, we are accessing that attribute species before setting it, right? So the problem here is with these two statements. We are accessing the species attribute first, and we haven't set it yet, and we are setting it to some value in a later statement. So obviously, if you run this code, this statement will definitely result in error. So it's almost the same thing as we did on the last slide, but here we are trying to not to access any attribute directly. Instead, we are using a getter method, right? So this seems to be a good approach. We are not defining any extra attributes or initializing them unnecessarily. But the problem here is that accidental access to any attribute before it has been set, that will result in an error. In error, right? Now, in next class, we'll see an even better method to overcome this problem, where we won't need to unnecessarily initialize these attributes, and this problem will also be solved. And that will be through initiator methods, but we'll see that in next class. For now, let's move on to some other points related to this class definition. Now let's see how can you document a class. By documentation, I mean that you can provide simple text that can help the user of your class on how to use your class, right? Like you can give description to the user about your class. And we had been doing this using doc strings for functions in CP, right? So same doc strings will be used here. And we know that whatever you write in doc strings, that appears when you call help on that particular function, right? So let's see how we can do this here. Now, what happens in a class, you can provide doc string at two places. You can provide documentation for a class, like a description of your class, and then you can provide description for each of the methods too, right? So here, let me first write a doc string for the class. So that will naturally appear just below this class definition here, right? Now here you can see these triple quotes. If you remember, these triple quotes, they just indicate a continuous string. So this is a continuous string of 2 lines. Class animal defines an animal object having something, 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 whatever you want to write. And then it has 2 attributes and 3 methods, right? So this is a small description of my class that I have given here in this doc string. Then I can add individual doc strings for each method too. So for example, for this set species method, this is my doc string. This is a setter method for the attribute species, right? So similarly, you can add doc strings to your other methods too. Now, when you run this using help, you will see this appearing there, but there you will notice a lot of other information, some default information also appears for a class. In fact, if you are not documenting your class using doc string, then also idle provides some default documentation for your class. Now let me show you these 2 points in idle. Now here you can see idle window on the left hand side, right here, the shell. And on the right hand side, I have opened a file. This is the same file that I have provided to you along with the lecture. This file contains all the codes that I'm almost all the codes that I'm using in my lecture number 5, right? Now, this code has been arranged slide wise. Like you can see here, slide 5. This is the code that I discussed on slide number 5. So if you want to test that, you just uncomment this portion and then you can execute and see whatever you want to test, right? So similarly for slide 6, slide 7, etc. Right? Now let us come to slide 10, which was for documentation. Now this first portion, let me uncomment this first portion first. Okay, here you see this is that same class, but I haven't added any of my own doc string. That is the same class with same methods and attributes, but with no doc strings, right? So let's see what automatic help does idle provides on this function. So sorry, for this class. For that I need to run this first. If I don't do that, then idle won't be able to recognize my class animal. After that, you can use this function help, and in round parentheses you just write the name of your class. So here's the help. This is the default help on class animal in module main. We know there's a built-in module and all our code just gets saved there. Here you can see is the list of my methods: set language, set species, speak, and it is there automatically, right? I did not write any doc strings for this. Similarly, if you see this last portion here, we can see the list of attributes, language and species, right? And their initialization values too, right? Now for now you can ignore this middle portion. Actually, it contains some special methods. These are called dunders, and we'll be discussing them in upcoming lectures. So for now, you can just ignore this portion. We are only concerned with this method list and with this attribute list, right? So this is the help that automatically appears when you call help function without using any customized, doc strings or documentation. So let's just comment it out again and uncomment this second portion. Now, the second portion is the code which contains some doc strings of my own. As you can see here, here is my description of my class. Class animal defines an animal with a specific species and language, and then it has 2 attributes and 3 methods and so on, right? Similarly, I have written doc strings for just below these method definitions too. So these should also appear in help, right? This and this one is for speak, that this method shows how an animal talks. So we just execute this. Oh, right. Okay, and then run this help again. Now you see there are a few changes. This is what I included in there, right? This is my help. It has 2 attributes and 3 methods, and class animal defines an animal. Similarly, here in method list, you see the description for each method is also there that I used or I provided through doc strings. See, so that's how you can document a class. You can, what would I say? You can document a class like you want, right? So, or you can custom document a class, right? So these were the 2 things that I wanted to show you here. Now let's get back to. Now, before moving on, let's do some practice problems to strengthen whatever we have studied so far. So this is the first problem. A very simple one. Here we'll define a class called point, and this class will have 2 attributes, x and y. and these methods. Actually, this point is it represents a point in a 2D plane. So in a 2D plane, that point will have two coordinates, x and y. So actually we are defining a type point which will represent a point in a 2D plane, right? So I'm defining here these four methods. The first one is set x, second one is set y. These are the setter methods for x and y respectively. X and y are the two attributes. And then we have a get method. This method is a common method for reading both the attributes, right? So it will return the values of x and y as a tuple. We know that this is a tuple notation, right? The values placed in round parentheses that represents a tuple. So we'll do this. And in the last function, what we have, we just want to move the point. So we provide some values, and these values will be added to x and y respectively. Like dx will be added to x and dy will be added to y, right? And that will behave as if we have changed the location of the point, right? So it's a simple class. Now let's see what code we have to write. First, this class statement, class is the keyword, point is the name of our class, and then colon is the part of syntax. Now, we saw two methods, in fact, more than one methods for defining attributes. This is occupying unnecessary space in the sense that we need to do this initialization, which we do not want in many cases. But let's stick to this first method because it's easy. So I'm defining first attribute x, and I'm initializing it, or I'm linking this to an object, to an integer object 0. Or you can say I'm simply initializing the first attribute to 0. Same case for y. And then we have our first method, setX. This is the setter method. Now I hope you remember to write this self as the first argument. It's a default, not a default, like it's part of syntax. You have to do this for every class method. And that second value is x coordinate is the value that will be passed by the user, and we'll assign this to x in the body of this method. So this method will contain only this one statement. And I hope you remember this too, that since x is an attribute of class, so you can access this directly using this self dot operator, right? So self dot x is equals to x coordinate. This will change the value of x. We define a similar method for y. I think it's self-explanatory. Then a getter method. Now getter method, it does not take any argument, but self has to be there. So I'm writing this self as an argument or parameter here, and it will again contain only one statement. Now if you recall, we studied that if you want to return more than one values from a function, they are automatically returned as a tuple. Like here I'm passing back two values to the calling function. So these two values, x and y, they'll be placed in a tuple, and that tuple will be returned to the main program. So we don't have to do anything explicitly here. This method will automatically return a tuple value to the calling function, right? Now the last method, move. Now move contains self, and then dx and dy are the two values that user of this method will provide. And we just need to add dx to x and dy to y. So this is the first statement, and this is the second statement. And you see dx and dy, you don't have to use self with these, because dx and dy, they are not the class attributes. You use self dot notation only with class attributes. So these are the four methods. Now let's write some code to test this. Okay, I'm defining a class, one attribute p1 of this class point. Okay, let's see the code first, and let me show you what output we'll get for this. Right now, first statement, p1 is equals to point, that will initialize or instantiate an object, and that object is referred to by p1. The second statement, it simply prints the coordinates p1, because p1 dot get will return those values as a tuple. Now since we have not done any custom settings for x and y, so what will it return? It will simply return the default value. So this is the output of this statement, and you can see that it's a tuple, right? Because we know that function by default returns a tuple. Then the third statement, p1 dot set x 4, it will change x to 4, and p1 dot set y 7, it will change y to 7. So p1 dot get, I mean, now this statement will produce this, though this is correct because these are the values that we set for x and y through those setter methods, right? Now second last statement, move 1 1, we know what it will do. It will just change the position of the point, so it will add 1 to the x coordinate and another 1 to the y coordinate. So it should print 5 7. Last print statement should print 5 7. So that is also correct, right? So it was a simple class, and I hope it helped you revise that class definition and method definition concept. Now this is the second practice problem. Here we have to create a class student, and this student class will have 3 attributes: name, roll number, and marks. Now here you see name and roll number can easily be string type of objects, but for marks we have to take a list, and this list will contain marks for 3 quizzes, right? Again, this list could be an integer list or a float list. It's up to us, right? Now these 3 attributes will constitute this class. Apart from this, it will have these methods. We have to define getter setter methods for these attributes. They'll make 6 methods, right? They are really easy. Then there is another method, get student. Actually, this get student, it prints information about an student object in the given format. Like it will print student name, it will print his or her roll number, and then marks in this given format, right? And the last function, average, it will just return the average of the 3 quiz scores. That means we'll have to internally access that attribute marks, and we have to find average for that list, right? Now let's start coding this problem. I'll start by defining the class using that class keyword, followed by the name of my class, which is student, followed by a colon. This is my first attribute. Now we know this very well that we cannot write an attribute without initializing it in Python. So I have to initialize it to some value. So I'm using here none. Same case with roll number. I'm initializing it to a string none. And then this is my third attribute marks, and I'm initializing it to 0 0 0, right? Now first while writing methods, the first 6 methods were the getter setter methods. So let's write code for them first. We remember that writing setter methods were so simple. You just have to write that self and then a value that will be assigned to that particular attribute. So for set name, n will be assigned to name. And again, if you want to access that attribute name from the class, you have to write this self.handler. Same is the case for roll number, and same is the case for marks. Okay, for simplicity, I'm here considering that the user passes a list of 3 marks. Otherwise, you can write a better method for this. Like you can ask the user for entering marks specifically for each quiz, like enter marks for quiz 1, then ask the user to enter marks for quiz 2, and then ask the user to enter marks for quiz 3, and then just place those 3 values in a list and assign it 2 marks. But for simplicity, I'm just considering that the user passes that list to this function set marks, right? Same is the case with the getter functions. Not same case, but they are as simple as setter methods, even simpler. They just contain one argument, self, which is the essential argument, and it will just, each of them will return the value of a particular attribute. Like get name will return name, get roll number will return roll number, and get marks will return marks, right? So these were simple getter setter methods. Now let's come to the next 2 methods. Okay, this was an important method in the sense that we have to do something different here. So this get student was actually a kind of print function for student, a custom print function for student, which prints the details of an object in a specific order. So it does not need any specific parameter from user, but self has to be there. So the first line, print line, would be this. Student name, this is a static string, and this is the value that of the attribute that will be fetched from the class, right? So this is the first print statement, a similar statement for roll number. Okay, for marks, if you go and see the format, a couple of slides back, there you'll see first we have to write this heading marks. After that, we start writing marks of each quiz. So here, if you see, in order to extract marks for quiz 1, I use this notation. Right, this is the first element of the list, so I can access it through this index 0, and since it is an attribute of a class, so this should be preceded by this handler self dot, right? So this will actually extract the first value from that list, marks, right? Similarly, you can write the same statement for quiz 2 and a similar one for quiz 3 as well, right? So this is what this function was supposed to do. It was supposed to print the information of an object in this particular format. And the last one was average. Again, we have already seen how we can access members of that list. So we just have to formulate a formula, right? So this is the formula. You see, these are first element marks, or the first element of that attribute marks. This is the second element of that attribute marks, and this is the third element. We just need to sum them up and divide them by 3. That will give us the required answer, right? Okay, I have not written any test code for this here, but you can do that by yourself. I am leaving that to you. Also, I would like to tell you here that I have not included codes for these practice problems in that file, because I want you to write some codes by yourself also. Otherwise, you won't remember small things like the syntax and, the importance of this self. When you write the code by yourself, you'll make mistakes, you'll make typing mistakes, and that's how you learn, right? So the code for these practice problems, they are not there in that file, right? Apart from that, all other codes, they are there in that file. Now this third practice problem is for you guys, so you'll do this by yourself. Okay, that's all for today. This is a quick recap of what we have done today. We learned syntax for defining a simple class. We learned how we can add attributes and methods to a class. And we also learned how to document a class using docstrings, right? Thank you.